Okay, good afternoon, students. So today we are going to discuss about quantitative technique topics, linear programming problem and its formulation. So there is a case study. The case study discussed about a linear programming problem, formulation topics. So a case study problem. First, what is the general form of linear programming problems? So it is the minimize or maximize, that's objective. First we calculate the objective of the LGT and then write the constraint, then what kind of the variable, whether it is positive or negative. So definitely it must be a positive, that is non-negative expressions. These three steps are called the formulation of the LGT. That's the general form. And so the first one is objective functions. From that, the second is called constraint and the third one is called non-negative expressions. So these three steps are formulation. So what are the formulation steps involved here? First, identify decision variable. How many variables involved actually for the formulation? And then second one is we consider what are the objective. From that, we find what is objective and then constraints. Finally, the restrictions. The restriction means how many decision variables are non-negative. So write all these the four steps for formulation. So using all these, we formulate an LTP. We discuss one case study. The case study for problem solving. So what's the problem here? Your firm manufactures product, two types of product A and B, and they sell them at a profit of ₹2 on type A and ₹3 on type B. Each product is processed at two machines. One machine is M1, another machine is M2. So type A requires 1 minute on processing time on M1 and then 2 minutes on processing time of M2. So processing type B requires 1 minute on M1 and process on M1, and the B requires M1 and 1 minute of M2 also. So the machines M1 is available not more than 6 hours 40 minutes. That means we convert these 6 hours 40 minutes to minutes. So 1 hour has 60 minutes. So totally 6 hours 40 minutes means 300 minutes. Then why? Machine M2 is available 10 hours also. So 10 hours means totally converted to 30 minutes. That is 30 into 10 hours. That is equal to 600 minutes. So during the working day, so formulate these standard paragraph as a LPP for maximize profit. So as per the formulations, first we consider how many decision variables and what are the objective functions. Then we formulate the construct the constraints. So that is less than or equal to. But here the problem is maximize. The objective function is cost function is maximum. That is the objective. That is optimal also. So here there are two products produced at companies. The manufacturer produces two types of product. One is A and B. Therefore, each product produces two variables. One is X1, another is X2. So these two are decision variables. Therefore, the decision variables are M1 and M2. So the product units type A and type B requires the processing time. Totally converted to processing time is X1 plus X2. And also the machine M1 is available not more than 6 hours 40 minutes means maximum the running time of machine is 6 hours 40 minutes. If it's converted to 2 minutes, then it is 6 hours. 6 hours means 6 hours into 6, that is 360 plus 40 minutes, so 400 minutes available. And machine M2 10 hours. The running time of machine 20 is 10 hours, so totally it's converted to minutes, then it is 10 hours into 60 minutes, that is equal to 600 minutes is the running time of M2. So this everything is possible. So M1 is a type 1 product running on M1, and the type 2 product running on M1 is 1 minute, so totally these two are running time is 400 minutes. So it's not less than 400 minutes, therefore it is less than or equal to that. And the second one, the product A is put on machine M2. There are two products on M2 and one product on M1. Type B in M1, M2. So 2 and outside is 1. So totally 10 hours. That means 10 into 60 is 600. So we calculate everything as a constraints. So x1 plus x2 is not equal to 400, and then 2x1 plus x2 is not equal to 600. There are two variables involved only, therefore x1, x2 are not equal to 0. So these are all the formulations. So what is our cost, the profit? So we are running our thing for purpose is a profit. So the type A requires, type A profit is 2 rupees and from type B profit is 3 rupees. Therefore the total profit is 2x1 plus 2x2. Because how many units produced from type A we don't know, that is x1 units and 2 is x2 units. The option is maximize the profit. Therefore the maximum Z is 2x1 plus 3x2. And subject to the constraints x1 plus x2 less than or equal to 400, 2x1 plus x2 less than or equal to 600, and the two variables involved, therefore x1 plus x2 less than or equal to 0. This entire setup is a formulation. Thank you.